give you some backstory here that you guys already know, but let's make sure we have it. Absolute value is defined as the distance between a number and 0, right? So, like, let's just say I say 4. That is 4 away from 0. Or negative 4 would be the same thing. Negative 4 is 4 away from 0. Okay, so the answer to the absolute value of these two circumstances is 4, because those numbers that I have placed in the bars are 4 away from 0. In a variable sense, if I say a variable like y equals the absolute, I'm not copying it right. The absolute value of y is 2. What can produce a distance of 2 away from 0? Well, there's two things that can produce a distance that is 2 away from 0. Positive and negative 2 can both fit this scenario. The absolute value of negative 2, yep, that's 2. The absolute value of 2, yep, that is true as well. Those should be closed circles. Okay? Or let's just say y's absolute value is greater than 2. This means whatever the number is more than 2 positions away from 0. Okay? That means whatever the number is more than 2 positions away from 0. Would you agree with me? Because it's 2, right? Here we said it's 2 and negative 2. So since I am saying greater than, this is going to look a little tricky. Negative 2, positive 2. I am going to dark circle both of these. I'm sorry, open circle both of these. Open circle both of those as I was doing it. Now it looks like eyeballs. Which numbers have a distance greater than 2 from 0? Well, this is where it looks a little crazy. Everything smaller than negative 2, those all have distance greater than 2 away from 0. So y is less than negative 2. And all of the things larger than 2. All of the things larger than 2. So these things or larger than 2. Notice how the original equation looked like this. Tell me what numbers you can put in for y that have an absolute value of more than 2 spaces. Well, when I looked at this as an equals, I kind of went back to that. I identified the 2's because I know 2 is our starting point. But they're telling me that the absolute value is more than 2 spaces. Everything in this direction and that direction have more than 2 spaces worth of distance from 0. Okay? And this is where it's starting to get a little strange. Okay? Maybe I'll say to you the absolute value of y is less than 2. The absolute value of y is less than 2. So still continuing on the path of the land of 2's, 0 to negative 2. I'm going to open circle my 2's. The only numbers that are fewer than 2 spaces away from 0 are these, right? This negative 1 is 1 space away. This 1 is 1 space away. So those numerals only are the numerals that would satisfy this particular inequality. Now, to indicate that in a graph looks like that, but to indicate it utilizing a less than or greater than type symbols, it looks like this. -2 is less than y, which is less than 2. Because the y that we graphed falls in between there and there. Okay? Looks like a little fish. Okay? The y information that we graphed falls in between. Now, I'm going to tell you, graphing for this lesson is going to be your friend. Because no matter how many times I say this to myself, I've reviewed and explained and tried to teach this lesson to myself many, many times, it still requires me to stop and think every single time so that what I am stating does indeed meet a correct response. For whatever reason, absolute value is just not a real quick memorized thing when we're dealing with inequalities. So I'm going to jump right into the deep end of the pool here and see how I can show you all these and what they might look like. Example 1. So for example 1, instead of me giving you something clean and pretty like this, I am giving you something that is not clean and pretty. And it's going to look like this. So if I'm going real slow, this is why. I've found that over the years, this is just a lesson I have to be very, very careful with. Okay. The result of this mess is 5 spaces away from 0. Okay? That's what this says. The result of this mess is 5 spaces away from 0. Okay? Now the question is, we need to find out what value for S, when plugged in here, will produce a number that is 5 spaces away from 0. Okay? Tricky stuff, right? This is 5 spaces from 0. The question is, what S will make that happen? What S value will make that happen? S is the variable. I don't like working with S, by the way, because it always looks like a 5. So, let me ask you this. In the land of numbers, which two numbers are 5 spaces from 0? And -5. Which means, solve this for 5 and -5. Why? Because whether this is a -5 or a 5, that what is produced is 5 spaces from 0. Okay? I'm going to let you look at that for a second, and then I got to flip it over. And here's how you solve it that way. The original equation, I'll just rewrite it really quick, is 2s plus 3, absolute value is 5. So here's how we're going to solve it. We're going to say that means that this or this is true. Because both 5 and a -5 are 5 spaces away from 0. Both 5 and -5 are 5 spaces away from 0. Simply solve. Subtracting 3 here and here, you end up with 2s equaling 2. So s is 1. You end up with 2s equaling -8. So s is -4. Okay, I have 2 answers. If I plug in this number right here, 2 times 1 is what? 2 times 1 is 2, plus 3 is 5. Does 5 produce an absolute value of 5? Yep. 2 times negative 4 is negative 8, right?
Yeah.
Add 3 to it, you get a negative 5. Does negative 5 produce an absolute value of 5?
Yeah.
Yes. So your answer to this looks like this. Those are the two things that produce, when inserted into the S position, an absolute value of 5. Graphing it looks like that. Okay, that is the first example. The next example. Now, depending upon how you like to do these, and I go back and forth with how I want to do these, I'm just going to go with the way I like. Here's example 2. 3 minus K produces an absolute value of fewer than 2 spaces. So if it's fewer than 2 spaces away from 0, that means this thing lies in between the 2's. Okay, let me show you what I mean. The numbers that produce an absolute value of 2 are negative 2 and 2, right? Mm-hmm. Don't look too closely at this graph because this isn't the answer, but I'm trying to illustrate something. That means the result of the absolute value of 3 and negative K has to be fewer than 2 spaces. Okay? Now, why that applies here, and this isn't your real graph, but I wanted to use this fewer than drawing. Why that applies here is because the result of this is going to fall in between whatever the values for K are that we solve for. Because whatever K is will produce a value in between these two things. So let me show you how to solve that. There's 2 different ways of doing it. You can 3 minus K is less than 2, fewer than 2 spaces. Negative 2 is less than whatever this is. So see, negative 2 is smaller than this, which is smaller than that. That's one way of doing this. Okay? That's one way of doing it. To solve, subtract that negative 3 from all 3 sides. You end up with what the K value is. This one is tricky though. Negative 5 is less than the opposite of K, or negative 1K, which is less than negative 1. Okay? Since it's the opposite of K, we have to flip the whole thing. And when you flip the whole thing, you flip the signs. 5 is greater than K, which is greater than 1. Now, would you say that this falls in between these 2 numbers based on that? Yeah. Which is how we know that we're probably correct here. I'm going to graph it for you down here. 5, 1, 0. Five is greater than K, which is greater than 1. Okay, this is the method that the book will most often teach. Okay, and this is the method you will most often see. The other way folks have done this is they have solved this. Negative 2 is less than 3 minus K. And then they've solved the other piece. So this is this. And then they've solved this. 3 minus K is less than 2. And if you do it that way, you're still going to end up with the same thing. Minus 3, negative K, negative 5, K, 5. K is greater than 5. Negative 3, negative K less than negative 1, K greater than 1. What this does is it simply allows you to break it apart. If you want to do it that way, you can. Okay? Just recognize that there's two pieces to the puzzle. There's this piece, oops, I used the wrong color. There's this piece, and then there's that piece. Each of them utilizing the 3 minus k scenario, okay? That's example 2. Example 3. They do get trickier, I promise you. And I'm sorry to say that, but I'm just going to warn you. Example 3 looks like this. 3 halves is smaller than or equal to the absolute value of 2 and 1/2 x. Remember how I said to you that this kind of, I have to keep saying this to myself over and over again so that I don't make a mistake. So because I've written it backwards, or because I've written it this way, it gets me mixed up. So this thing's absolute value is greater than or equal to 3 halves. Okay? Whatever this is has an absolute value that is larger than or equal to 1 1/2 spaces from 0. Which means whatever you graph is going to look like that. We just don't know what it is yet. Okay, the one we just did a second ago was a in-betweener. This one is going outwards because the absolute value is bigger than 1/2, which means it's 1/2, negative 1/2, 1/2. But let's solve it and see what our actual information is. So I hate it written this way, so I'm going to just rewrite it. 2 plus 1/2 x is greater than or equal to 3 halves. Okay, that's how I prefer to write it. So let's take and solve it. The first way we're going to solve it is using it exactly as it is. Okay, just remove the absolute value signs. The result of this thing is going to be larger than or equal to 3 halves. But since it's absolute value, we have to solve it for the other alternative, which is 2 plus 1/2 x is less than or equal to negative 3 halves. Remember, things that are smaller than negative 3 halves go in this direction, and they do produce an absolute value bigger than 3 halves. Things that are bigger than positive 1/2 would go in that direction, producing an absolute value larger than 1 1/2. So let's subtract 4 halves. I'm working fractionally because we've got a fraction on the right. Okay, working that, we end up with 1/2 x is greater than or equal to, that's negative 1/2, right? Over here, 1/2 x is less than or equal to negative 7 halves. Solve by multiplying by the reciprocal of 1/2, 2 over 1. X is greater than or equal to this result, which is negative 1. And x is less than or equal to this result, which is a negative 7. Okay, remember how I said because what we're producing produces a smaller absolute value than 3 halves? I mean a greater absolute value than 3 halves? Boom, boom, produces bigger absolute values than 3 halves. The x that you can have that will make that work, anything smaller than negative 7 and anything larger than negative 1. Okay? The only thing I can tell you guys about this is it takes practice, 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 which is why today is odd. Okay? That's why today is odd.